All right. So we now know the method for proving the area of a circle, or at least one of the methods. Probably the hardest. And that is to integrate this function of 2 square root of r squared minus x squared dx from negative r to r. Just integrating that. And we know that the result would be pi r squared. However, I don't mean at all to make this method, this going from one to the other, look easy. Now, the results make sense. The way we came up with this formula, honestly, we're taking this 2 is here because we want twice the distance on each side of this circle. It comes from the Pythagorean theorem. These bounds, yeah, you're going from one edge of the circle to the other. That makes sense. Yeah, it all makes sense, but the method of getting from this formula to that is not so clear. I mean, sure, you could just plug this in and end up getting this formula, but how do we know how to solve this? Well, there's a lot of little intricate little details that I use, little formulas and things we know in math to get around these problems on this equation. But I don't know, I've never really covered some of them, so let's do them now. Here's the first one. All right, this one's big. It's very important. It's the double angle formula. It says that cosine of 2 times an angle is the same as cosine squared of just the regular angle minus sine squared of just the regular angle. That's an interesting result that relates and 2 times an angle to a single angle. We can also use this guy of sine of 2 theta is equal to 2 sine theta cosine theta. That is also useful. These are the double angle formulas for cosine and sine. And they're neat, and they're also really useful for converting and finding values of trigonometric, whatever, functions. You get the idea. And using all this work, we want to try and prove the volume of a sphere and also the formula for the indefinite integral of a circle, because we can actually use it to find some results that would seem impossible by doing it this way. So let's first just double angle formula. So that's what this video will be on. Double angle formula. So if you're ever trying to prove something or demonstrate something or even just find something, your number one ticket, if you're doing trig, is a unit circle, because unit circles are just so rad. So let's draw these cuts. This is our plane. We're going to work on just the positive for here. Let's make our circle orange. All right. So this is a unit circle, so it has a radius of 1. That's easy to say. All right, so here's what we're going to do. We're going to prove this guy by using a rule we know as, well, you probably don't know it yet, but we're going to prove that rule first, because right out of this rule comes the cosine and sine double angle formulas. And it's called the angle addition formula. All right, so what is cosine of one angle plus another angle going to be? How can you relate those? So that using that, we can easily prove this guy. All right, because it's just 2 of the same angle. So let's draw one line. This is going to be alpha, angle of alpha. Let's draw another line. All right, we want to add these angles together. And so this is going to be put on top of this guy. It's going to be an angle of beta. Look at those beautiful colors. All right. So here's the cuts we're going to make. All right. So this length is 1. We know that. kind of working off of memory here if I can remember it right. So this is one that is the most useful part of this whole proof. So let's drop a line down. That's cool. Here's another thing we can do about this. So that made a right angle here. Another thing we can do is make a right angle right here. So let's do that. Ooh, look at that. So that's neat. And what's another thing we can do? Ooh, we can drop a line down here. What's another thing we can do? Ooh, we can stretch the line right out here. And turns out this whole sketch is all you need to solve this problem. You just have to realize what parallels, that's kind of a pun, because you are going to use parallel lines. What parallels show up in which you can prove things are equal. Because if you get one result for something and then another, you get the idea. So what can we do here? Let's first find, let's deconstruct this, all right? There's quite a few triangles going on. There's this triangle here. You can see that. There's this triangle. There's this big triangle of A plus B, right? That shows up. And there's this alpha triangle right here. Yeah, so there's 3 triangles. So let's start with the easy one, which has a radius of 1. And so is the triangle of angle B. Let's just draw all in orange here. All right. Let's find some lengths. So we know that this length, let's turn sideways for a second to help us out. So this angle is beta. That's technically known since we labeled it as beta. So sine of beta is this guy. And cosine of beta is that guy. Done. All right, let's go back. Sorry. All right, so I'm just adjusting that. So, yay, we solved that. What else can we do here? Oh, here's an angle I forgot to mark. So if you measure this triangle right here, see that, yeah? This guy is going to be 90 degrees. I could work in radians, but I'll just work in degrees for a second. 9 degrees, right? Because these two sides have to add up to 90 degrees. So 9 degrees minus alpha minus beta. All right, what has to also be true? Well, this angle right here, if this is beta, this has to be 90 minus beta. Agreed? Yeah. So we're almost done here. If this is 90 minus beta and this is 90 alpha minus beta, then this is that whole angle. So if you take this and subtract this guy, then you should be left with what this angle is right here. Let's make it a little smaller so it stands out. All right. So it's separate. So 90 degrees minus beta minus, we're just trying to solve that, minus 90 degrees minus another alpha. A minus is a plus, so plus an alpha. Then a minus again is a plus a beta. What cancels here? Well, basically everything. We have a negative 90, so those go away. We have a negative b and a positive b, so those go away. And so all we're left with is alpha. It's a funky looking alpha. All right. That makes sense. It's the alpha male. No, whatever. Sorry, I couldn't help saying that. So yeah, we now have another triangle here we can work with. And so what does this triangle tell us? Oh, it tells us everything. It was a secret triangle that you didn't notice. All right, so alpha. And what is this length right here? Well, this length is sine. All right, so sine B is exactly the hypotenuse. And so that is the scale factor that we multiply by these two sides. Writing this is more obvious if we turn it on its side. This length is the cosine of alpha, except for it's scaled up by sine of beta. So the length is cosine of alpha times sine of beta. Then we can use the same trick here. This guy is going to be sine of alpha. And then we have the scale factor of sine of beta. All right. Ooh, look at that. So that's another triangle we solved. And what do you notice about this length? This length shows up right here. So there should be a way to use this alpha triangle to find it. And that brings us to this triangle. Yes, alpha triangle. The big alpha triangle, that is. Well, we know that this length right here along this side is cosine of beta. That will scale up these sides on to the left and right. So this is alpha. So this length is now cosine beta. That is the radius, in a sense, hypotenuse. Alright, it's cosine beta times it's the cosine of alpha. Nice. And then what's this height here? That's just cosine beta. That's the hypotenuse. Multiplied by sine of beta, of alpha. Ooh, we just found this guy. That's same as this guy. Look, this can be transposed over, moved over. Look, that, man, there's so much symmetry here. Alright, what's this whole height right here? Alright, from the top, well, that's an angle of alpha plus beta. Here, let's just write out this giant triangle. I guess I'll draw it a little tiny. I kind of want to do light blue. I like that color. Alright, so this whole thing has 1 as that height. As that length. And now the height is going to be sine of alpha plus beta. Nothing more than that. This bottom is going to be, here, I'll just write it off here. Cosine of alpha plus beta. The length is 1, and so you're just multiplying by 1, which doesn't change it. So this guy is cosine alpha plus beta. Ooh, you should be, there's so many things here that overlap with different values to them, in a sense. Alright, so we have this giant angle right here, this little piece. And then we have this guy turned on its side. We have this guy here, that small angle right there, that small triangle. And then we have this guy with alpha. So now it's just a matter of putting these ideas together. Alright, so it's all about connecting these guys to all of these guys. Right, this one to that. Alright, so let's take it to the next page. Ooh, it's so great. I love this proof. So we have sine, let's do sine alpha plus beta first. So sine alpha plus beta. What is sine alpha plus beta equal to? Well, the sine value is this whole length. And so it's the same as this piece, which is cosine alpha sine beta equal to cosine alpha sine beta. Alright. Plus this height right here. What is this height? Well, it's just this height, which is cosine beta sine alpha. So this is plus cosine beta sine alpha. Look at that. That is symmetry if I ever saw it. You see this cosine, you see this cosine. This is cosine of alpha, this is cosine of beta. This is sine of beta, and this is sine of alpha. So you just interchange them. So that's equal to sine of alpha plus beta. That is the sine addition formula. Angle addition, whatever. Is probably a specific name for it. Now let's bring it to this bottom part. This one's a little fancier. Alright, because this length is smaller than this whole length of cosine beta, cosine alpha. So let's write that. Cosine beta, cosine alpha. That is this whole length right here. And so this is a piece of it. So it's cosine alpha plus beta. This is equal to cosine alpha plus beta. Alright, except for that's also plus this length right here. Ooh, look at that. That mirrored sine alpha, sine beta. That's so awesome. Sine alpha, sine beta. Alright, let's subtract this piece to that side. And so now we have, let's put this guy in front, cosine of alpha plus beta equals, ooh, look at this. We have cosine beta cosine alpha minus sine, let's put beta in front, beta minus, so minus sine beta sine alpha. Ooh, look at that. That is just beautiful. This is the cosine one, and this is the sine one. If you're ever adding angles, that's the same thing as multiplying them like so. So if you have, I don't know, if you're ever solving a problem in trigonometry, just try and find a result, these two formulas will help you out if you can decompose something into something you know the value of. All right, so now step 2. Let's set alpha and beta equal to theta. If alpha and beta are both theta, then sine of alpha plus beta is the same as sine 2 theta. All right, and cosine of alpha is the same as cosine of theta, and sine of beta is the same as sine of theta. Now, taking it further, we have cosine of theta, and we have sine of theta. Just like making that substitution. And so what is this? What is this? That's the same thing. Cosine theta, sine theta, and cosine theta, sine theta. So we have 2 cosine theta, sine theta. Ooh, look at that. Look at that. Oh, I mean this guy, the bottom one. Now you can expect what's going to happen on the top one, which is now the bottom one here. If you make them both the same angle, right, then we're going to get a cosine 2 theta. Good, because that's 2 of the same angle. That's going to be equal to cosine of the theta times another cosine of theta. That's same as cosine squared. And then a sine of theta times sine of theta, which is same as sine squared theta. Sorry. There you go. Sine theta squared. And what? Ooh, that's the exact same thing. So these are the double angle formulas derived from the angle addition ones. Angle addition. That is super rad. All right. And now this one can also be rewritten. So let's just rewrite its other forms. If you make cosine squared 1 minus sine squared, because that's the same thing as cosine squared, then you have 1 minus sine squared minus sine squared. So you have 1 minus 2 sine squared theta. All right, that is equal to cosine of 2 theta. And what's also equal to it is, what if instead of substituting 1 minus sine squared here, let's substitute 1 minus cosine squared here. So we now have cosine squared theta minus 1 minus a negative cosine squared theta. So now we have 2 positive cosine squared thetas. This is awesome. Cosine 2 theta is equal to 2 cosine squared theta minus 1. Or 1 minus 2 sine squared theta. Or cosine squared theta minus sine squared theta. It turns out that this one is a little more helpful because you can easily convert a sine squared into a simple cosine. Right? Nice. All right, in the next video, we'll make some progress on trig substitution so we can understand this problem better.